On the bench I have a Racal-Dana 2101 frequency counter. Now this thing goes up to 20 gigahertz. Now I've got nothing which can generate frequency up that high, and I already have tested things. I'm not going to demonstrate it again right now, but I've actually verified that this input works, this input works, that's 80 megahertz, that's 1300 megahertz, both of those work. The high frequency one does not work, and that is 500 megahertz to 20 gigahertz, and that one isn't working. I put a 1 gigahertz signal in there, which is definitely well within its range of sensing, and nothing. Didn't sense at all. So we're going to pull this thing apart and we're going to see if we can find what's wrong with it. I've already changed over to 240 volts. I think I did that in the live stream actually. I think I worked on this on a live stream previously, just checked it out on the live stream. So if you're watching this video, which has been pre-recorded, then make sure you check out my live streams in future. Because this I'm also doing a live stream right now. There's no washer on that one. Only one of the screws had a washer on, so someone's been here before and lost the washer. I haven't been inside this one yet. This is first time. Yeah, it is. I can see that wiggling. Let's pop those out. They're getting in the way. See if my spudger can do that bending. Here we go. That's better. Oh, there's a little diagram on the inside of it. Module cable routing diagram. Curious. I wonder what I thought that needed to be in there. Now it's doing some visual comparisons. Because of that is referring to these modules at the front here. So I checked to make sure they're right in case someone's messed it up. It could be something that easy, couldn't it? I doubt it, but you never know. It kind of tells you where they go, but these cables are really long. They're not exactly that easy to follow. So the bottom one is going to the front terminal, yes that's correct. And the right hand ones, the top one comes to the front one. Super long cables. Surprised they're that long. Anyway, yeah, they're correct, they're wired up correctly. They should have models in the correct places as well. So it should be PL6 at the top, PL8 on the bottom. That's what it's got up there, and it's got PL6, PL8 there, so that's right. So it looks like those are at least connected up correctly, that rules that out. So the module which says you're connected up to is that box just there, which is on the input side. Where to start? That's the question. I was kind of hoping I could find something simple. Now it says you've got some markings on here too, so someone's definitely been here. Of course there's a pen marks on this connector. Someone's had that off and made sure they put it back on correctly. Ooh. Previous repair attempt. That always makes me a little bit nervous. So I'm just going to remove this panel here. It's got like a rubber foot right in the middle here, which is resting against it, and it's not sliding very well. As you'd expect, a rubber foot is actually gripping. So I'm trying to flex it a little bit at the same time. There we go. We're out. Just want to do a visual inspection of the boards before I get too stuck into it as well. Some dodgy joints looking around here. Just not enough solder on them. Surprising. And I can see some wash marks over here. It may be factory. Looks like it's probably just washed off flux. Let's pull this cover off and find out what's underneath it. If there's anything interesting under there. Could be nothing. Just interesting to put a cover there. Could be just hot reflections because of the high frequency stuff going on. That screw is shorter than the rest. So is that one. The two screws this end are shorter. For some reason. Yep, there's more circuitry under there. That's plated as well. Just looking to see if I can see anything under here which looks burnt or damaged. Seeing as this is all the front end input from those modules, from that input we're trying to diagnose. There's one part here which is white, which I'm puzzled by. It looks like it might be cracked. So this is the part I was looking at, which sort of caught my eye because it's white and there's no markings on it, and it looks like it might be cracked. I'm not sure if there's a crack or not. The little line just there. I'm not sure if it is cracked or not. The question is, what are they? Are they special resistors? Don't know. Can you see that line? Right there. I'll have to look at the manual, see what it says it actually is. Something has gone wrong somewhere. We've just got to find out what it is. It might not even be that. So I was looking before at the solder joints on this board. So there's a few joints around which aren't looking great. This one here doesn't look quite right. Looks like there's not enough solder on some of these joints over here and over here especially. There's a few there which don't look quite right. It doesn't look so bad when I'm looking at it close up on camera though. But you can see this joint here doesn't look like it's got enough solder on it, maybe. Yeah, I mean, I don't know if there's an issue with solder joints or not. I'd be surprised if I'm not this suspicious about the solder joints. Still nothing obvious though. So I'm going to pull this module here out and let's have a look, see what's underneath it. Because it looks like the wire's long enough to actually do that. So I designed it that way, which is quite interesting. I was wondering why the wires are so long, but it looks like it's so you can get this out. Let's try and do physical inspection, because a lot of times I'll do a repair based purely on what I can visually see. Not always, but it's amazing how many times having a really good look over a piece of gear can find the problem. You know, there'll be some kind of clue somewhere. It says, you know, something's a bit burnt or a bit of discoloration, something like that. The amount of times that just doing a visual inspection will find the problem. See how long these wires. This flex is pretty good. Look at that, comes right out. Isn't that nice? So let's have a look around underneath here. And there's nothing that stands out there. There is the module on the side. ERA Technologies Sampler. Go on, focus. Focus, you bugger. Not on this. On that. There we go. RDS 45B2. But that would probably be the first point to check, is to see if we've got anything coming out of this box. Because there's nothing coming out of this box, there's a good chance I can't fix it anyway. But if it's after that point, I might have luck. Because these are just basically mixers. PL8 is the LO module, Local Oscillator. And this is the IF module here. So they're both doing the down conversion, or use a part of down conversion. You probably have to look at the manual and figure out exactly what's doing what. Make sure we've got the connections on there. So IF marked on there, and that's going through to the IF board, so that's probably correct. And so this cable here, I should be able to measure a frequency coming out of it. I should be able to see something on here if it's working. I don't know what that frequency will be though, that's the thing. Because it's been down converted. It could be a 10:1 ratio, something like that. I don't know what it'll do. I'll have to look at it in manual, find it out. So I'm testing the local oscillator on this thing. I've got it disconnected right now over here. Testing the output. Now I should be able to punch in a code which will cause it to lock to a certain frequency, and I should also then be able to see what's going on. Right, so first I put some codes in, which is in this case I need to do 41 shift store SF. Then I need to do 37 is the next one. 37 shift store SF, and I should be able to do that to enable it. 0 means locked right now. Will it stay that way? I don't know. Sometimes I'm seeing 1, which is unlocked. So now I'm going to put in 325 shift megahertz store track, which should set the local oscillator to 325 megahertz. What I'm going to do first though, I've got my scope powered up, ready to go. Let's just probe on this and see what we're getting. I don't have a quick connector for this unfortunately, so I have to sort of mess around a little bit. So I'm currently getting, I'm not sure, it's very noisy. I think it's scanning still, so it's lots of jitter in there. Getting around 260 odd megahertz or so there. 268, 276 I'm seeing there, 280, 284, it's like it's drifting up, 291, 303, it's slowly drifting. 343, 344, 344, it's kind of stopped there, which is interesting. So let's do this code on here and see what we get. So 325 shift megahertz, I would have thought it'd be the other way around, but maybe there's a reason for that. Store and then track. That should lock that to 325 megahertz on the LO. So let's probe this again with the scope. I'm not seeing 325 megahertz, I'm seeing about 355 or so. But again, I've got lots of jitter and noise on this scope, so you can't really see it, but you can actually see this is unlocking as well. So it's like the loop isn't actually locking properly. See, it's unlocked. Now I'm getting 320, 327, 325 now, 326. So it's not actually locked on the frequency it's supposed to do, but I don't know if I can trust that readout on the scope because it's very, very noisy. So here's the screen of the scope. I'll probe it again and I'll show you what I'm seeing. That's what I'm seeing. So not really right. It's like there's a lot of jitter in the actual VCO. I thought it would be a cleaner signal than that. You can see that it's just really messy. So that's a little bit concerning. It could be a loop control problem, it could be a divider problem, it could be a control problem potentially. Could it be a power supply problem? Being a little bit noisy like that's not a great sign. So now let's check the voltages just to be sure what I've actually got here. So pin 1 and pin 3 of that connector are plus 5 volt MF. And MF is supposed to be a very low noise power supply. and you can see there's actually a bit of noise in there. I've just got DC coupling obviously right now. I'll do AC coupling shortly and look at that a bit more closely. So it's pin 1 and pin 3 both the same. Pin 11 is supposed to be -5, so that would be about here somewhere. Where is it, that one? That's pin 11 there. And see how much cleaner that one is, and that is -5. 5.2, which is correct, pretty much. It's got a little bit of ripple in there, but we'll see what that does afterwards. And then we've got pin 19, which should be +15 volts, which is up here, and you can see it's also got lots of noise. That is very noisy there. The mean's about 16, it's jumping around, so it's a bit hard to see what it's actually supposed to be doing. You know, there's a waveform in that too. See that? Look at that ripple on there. And it's also jittering around everywhere, so it's getting some noise feeding back. It's not a consistent waveform, it's a different frequency, it's always altering, which is interesting. And it's doing 15.6 volts RMS with a 4 volt peak to peak ripple, which is probably excessive. And if we go back to pin 1 and 2, the same settings, we're getting something similar, 720 millivolts ripple on there. Is it my probing? Potentially. Let's take the ground lead off, in case it's because I'm going to the casing rather than to a proper ground point. And I'll probe again on those same 2 pins. And now it's got lots of noise in there, so that's really not helping. Yeah, so that's not helped at all. And that frequency is about 90 kilohertz, interestingly. So there's something coming back. I think it's back feeding to the outputs. So let's just do AC coupling. Wind this up a bit. So back to pin 1 and 3, which I linked together anyway. And you can see it's just incredibly noisy there. That's just a mess. Pretty sure it's not meant to be like that. So that's like 700 millivolts peak to peak on there. So maybe what I should just do is go through and recap the bloody power supply and have done with it and see if that fixes the problem. Okay, so that's that one. Let's do the pin 11. That's pin 11's noise, which actually isn't looking too bad. Now, considering that pin 1 and 3 are supposed to be very low noise power supply, it's supposed to be really good ripple, it's worse. So it's quite interesting. I think that's got some problems. And this is the 15 volt rail here. Oh god, look at that one. Yeah, that's just not good, is it? That's 3 volts peak to peak according to that. That could do it. So I think what I'm going to do is go through and recap this thing. Now there's a few little capacitors under here. I don't know, half a dozen underneath this module section here, which I've currently removed, just sitting over here in the back there. So I've got to do those ones there, and I also got to take the GPIB board out over here, because there's a whole bunch of power supply stuff underneath here, which obviously I need to try and get to, and I've got to take the GPIB board out to do that, but not a big deal. I think if I recap it, then I know it's done. I mean, this thing is 1987 dated, as you can see from over here, 1987, 3387. That's the time frame for this thing, so it is 34 years old. So some of these caps are probably well past their use by date. Some of them may be absolutely fine. I mean, high quality caps in these gears, so it could actually be the caps are absolutely fine, but the fact I'm getting huge amounts of ripple on there, that's a suspicion that, hey, there's something going on which shouldn't be going on. So it's best just to replace all the caps, go through the whole unit, do the whole lot, then I don't have to worry about it. I know it's okay after that point. If there's anything else still going on after that, then I know I need to dig further. So in these modules here, that's the LO, that's the IF, there are some special surface mount electrolytic caps in there. They're special rectangular ones. I've never seen them before. You know, I've never come across them. They are electrolytics. So it could also be that they are a problem as well. It could be all the capacitors in here have failed, because it's got this extra smoothing on the boards, on the ICs and stuff for decoupling and what have you on boards. So these may be bad as well, which means that the whole lot just can't cope. POLs and VCOs do not like oscillations. Any kind of power supply noise can cause all kinds of problems, especially with the loop filter and stuff like that, because it will cause jitter on the loop filter, then the POL will try and correct for it, and it'll just be out of control and just go over the place. So that's what I'm looking at right now, is to recap it. I'll redo this board and then see how that goes. If that doesn't work, then I'll look at this one and see how that goes. But right now I'm kind of suspicious that that may be what the root cause is. Maybe it could be something else, but yeah, I mean, this output isn't right. But as I don't have proper cables hooked up to it right now, it's a bit hard to do proper measurements on it. You saw how noisy it was. That could be because of the power supplies though. So I just removed the very first capacitor from this. This little one that's just underneath the OC exciter back here. So I just removed this and we're going to check it. It's 1 kHz test frequency and this measures 6 microfarad. This is a 47 microfarad part. So this is a long way off. And if I change to be manual ranging, capacitance, series capacitance, we changed frequency, to 100 kilohertz, standard frequency, it's rubbish there. If I do 100 hertz, 8.2 microfarad, still the same. If I do ESR, 64 ohms. So that is completely fried. And that's just the very first one. And normally the small ones are better than the big bulk capacitors, so I think I'm going to have to replace the whole lot. So the very first one I tested is definitely really bad. So yep, that'll do the whole lot. So I've replaced all the capacitors on this main board now, and I've just replaced the capacitors on this pre-scaler board as well. These axial capacitors. So those are all done as well. All the capacitors I've tested so far, the ones I've removed, I haven't tested every single one of them, but the ones I have tested have all been bad. Recapping the entire thing is definitely the right thing to do here. So this out of interest, let's test all these capacitors. So if you want to skip this if you want. But so this is a 47 microfarad 25 volt cap. I'm testing at 100 hertz. 8.3 microfarad 67 ohms. Bad. Another 47 here. There you go, 5.9, 130 ohms. Bad. Another 47. 13, it's got slightly better, 20 ohms, still bad. Another 25, well, another 47 I should say, 25 volt, 13 microfarad, 17 ohms, still bad. 15 microfarad, 17 ohms, bad. It's another 47. What's this one here? This is 100 microfarad, 20 microfarad, 23 ohms, bad. This is another 100 microfarad, 82, better, but still bad. This is 47, 4.4, 95 ohms or so, bad. What's this one? 4.7, 4.5, 32 ohms, slightly bad. The 4.7s actually did slightly better, the ones I checked, but generally also bad still. 15 microfarad, 17 ohms, this is another 47. Another 47. Getting 2 microfarads, 2K. So this is why I generally recap as a matter of course, because you never quite know. Instead of just wasting time checking everything, just replace them. 5.5 microfarad, this is another 47. This is another 47. 16 microfarad, 15 ohms. This is another 47. 6 microfarad, 124 ohms. They use quite common values in these, 47s and 4.7s mostly in here, which is quite good. 3.1, half a K. We found a good one yet? Nope. 8 microfarad, 70 ohms. There's another 47 by the way. This is another 47. 7 microfarad, 100 ohms. Another 47. 2.3, half a K. This is a 4.7, 6.3 volt. Oh, sorry, 63 volt. 4.7. This one's not looking too bad. 28 ohms, slightly high, but might be okay. Let's say this 4.7s have been doing slightly better, so it's marginal. It might be right. Might be the first good one. I'm still going to say no. This is another 4.7, I think. Yep, 26 ohms. It's another 4.7 again. Yep, 31 ohms, that's bad. .9, 18 ohms. This is probably still good. So I think that's a good one. This is another 47, oh sorry, 4.7. 4.5, 35 ohms, bad. Those ones have been done. So we've got some 1 microfarad here, I think. That's a 10, so that's 10 microfarad, that one. 1.4, 16 ohms. Yeah, might be alright. Marginal. This is a 1. Very high resistance, 52 ohms, too high. That's bad. 56 ohms, bad. Potentially, I mean, it might be alright, but it's really high. 60 ohms, bad, I'd call that. Okay, I'll say those are bad ones. What's this one? Another one. 72 ohms, bad. I mean, if I compare those to a newer, well, these have been sitting here for a while, but they're unused. This is a 1 as well. 28 ohms. So, that's kind of what I should be expecting from them. This is a 47 axial, which is from the pre-scaler board. 5.7, 0.3 of a K. Same deal here. Yeah, 8.9, 140 ohms. Every single one is bad. Apart from, well, I had what, 2, which are probably borderline okay. It's another 47, that's also bad as well. This one is a 330 microfarad, 10 volt. (183 microfarad, 3.6 ohms). So that's bad as well. This particular capacitor is on the supply line which feeds the local oscillator, which had a lot of noise on it. So this is the capacitor supposed to do that smoothing. So this is probably the one that caused that main fault. What's this one here? This is a 470 microfarad, 40 volt. 366, half an ohm. Resistance isn't too bad, but the capacitance is way off. What's this one? 1000 microfarad, 35 volt. Yeah, resistance again isn't too bad. Capacitance is way off. And this one here is actually, I think this one actually measured kind of okay. So pin 5 is negative and pin 1 is 470, 100. Pin 1 and 5 is across these two. This one's a dummy pin, it's not used for anything. So negative that way. So it's 4.8 millifarad, which is okay. And resistance is also okay. So this capacitor might have been alright, but I've changed it anyway. I did test it before I bought this one next. I thought I was 3 legs, it could be a bit of a pain. But yeah, it's simple to replace that one. Now there's one capacitor I haven't changed, and it's this big one here. It's a 22,000 microfarad. That's on the 5 volt rail, and I did see no ripple at all on that 5 volt rail. If I remember rightly, I could have got that wrong, but I don't see any ripple on the 5 volt rail itself. So that capacitor is probably still okay. It's got 4 pins on the bottom of it, but it's only really just 2 pins being used. So I don't actually have any capacitors of that value anyway. So for now I've just left that one. Closest thing I've got is a 15,000. In here, 16 volt, and it's got these tabs on it. I've got these massive Nichicon ones, which aren't really suitable either. So I mean, if I compare it to this, I mean, can I read this one? I'm not sure I can even read this. There you go. So it's reading 12, 13, it's getting there. So you can read it, but yeah. That one there, I don't know, it may be alright. I might get some anyway, just to replace that one, but unless I have reason to worry about it, I think I will. But the fact that all these other ones have been bad, but these are Phillips caps, that's a different one. I'm not sure which one that actually is. I need to check on that. So yeah, I'm just testing this capacitor in circuit. You can see I'm getting 19.8 millifarad here. Oops, if I don't lose connection. Right, so it's not too bad. It's slightly off. 10%, yeah, maybe alright. So the resistance looks okay. So I'm not too worried about this capacitor because it seems to be kind of okay. I've just noticed on the GPIB board, which I took out, there's got one capacitor over here which is also a 47, and all the 47's been bad, so that needs replacing as well. I'm pretty sure of it. I'm not even going to test it, I'm going to change it. And just to say completeness, here's the capacitors poured out the GPIB board, and there we go. 8.2 microfarad, and let's just do the ESO on that one, just have interest. 52 ohms. Yep, bad. Right, it's powering up for the first time. Hopefully nothing goes bang. You never know with replaced capacitors, you might put one in backwards by mistake. We'll see. It's at least powered up. So what I need to do is inject something and see if it works now. So I put a connector on here. I've got my signal generator set to 1 GHz. So let's check this channel first, channel B. Just to verify that one still works. Channel B, there we go, the signal we're getting. So that's working still. That's because the OCXO is not currently warmed up. Neither has my generator. They both got other nice oscillators in them, so they both need to warm up and settle down before they be correct. But anyway, it's a start. This is working on channel B. So channel A, I don't think that would work because I think the frequency is too high for it. I think it only does 80 MHz, same on channel A. So channel C, channel C, which before didn't work. Hey, look at that, it's going. It's fixed. It was capacitors all along. Never trust capacitors. That's excellent. This is why I replace them all, regardless. Even if I think they probably don't need it, I just do them anyway. That's why I just blanket replace the whole unit as a matter of course when I'm doing test gear, because you never quite know what it could be. And in this case, I believe it was this capacitor here, which is stopping input C from working. I believe it was that one, because that's the main filter for the whole oscillator, and the oscillator wasn't in control, so it didn't work. Anyway, it's working now. That was a nice repair. Thumbs up if you liked it. Subscribe if you not already subscribed. Click the bell icon, all that sort of stuff, and I'll catch you in your next one. We'll fix something else. Bye.